Hello, greetings from sunny California, and we are going to solve this free response problem from exam 1. And the total current is our first question. Okay? And we're given the following information about this 3 light bulb circuit. We should recognize that the current in this circuit has to be the same at every point because there is a series circuit here. In other words, there are no choices for the current. There is only one path to complete the circuit from the positive terminal of the battery, over here, to the negative terminal of the battery, over here. So, whatever this total current flowing in the circuit is, it's the same through all the bits and pieces. So let's solve that out. Well, to find the total current, we can apply Ohm's law, which looks like this once we divide both sides by the total resistance. We then have 12 volts difference for the total voltage because we just have the one voltage source here. And we have a total resistance that, using our series circuit rule for resistances, we can find that the total resistance will be 10 plus 10 plus 5, which we know from here and here. That gives us 12 volts divided by 25 ohms, which in turn gives us just under a half an amp, 0.48, if I've punched it into my calculator correctly. Okay, so that's part A. Part B, it asks for the voltage drop across bulb 2. In other words, what is V sub 2 in the usual notation that we use? Okay, well, Ohm's law is going to be our friend again. I'm writing this so that we're clear that it has to be, well, if we want the voltage drop across number 2, then we need the current through the second bulb, and we need the resistance of the second bulb. However, because the current is the same everywhere in a series circuit like this, we can replace I sub 2 with total current, which we already know. We can replace R sub 2 with 10 ohms, which we get from the statement of the problem. And that means that we have 0.48 amps times 10 ohms, giving us 4.8 volts for the voltage drop across bulb 2. Now for C, the brightness of bulb 2 versus the brightness of bulb 3. Now they receive the same current, so a snap response might be, well, then they're going to have the same power being delivered to them, and they're going to be the same brightness. But we want to look a little bit closer at Watt's law, right? Watt's law, I think the most convenient form to use is this one, tells us that the power being consumed is going to be equal to the current squared through whatever item times the resistance of that item. Well, we just talked about how this, the same for bulbs 2 and bulbs 3 and everything else in the circuit, but this is different, right? At least for bulb 2 and bulb 3, there's a factor of 2 difference there, right? It's 5 ohms for R3, 10 ohms for R2. And so P2 is going to be equal to twice P3 because the resistance is twice as big. That may seem a little counterintuitive, right? More resistance, more power consumed? Bah, okay? But, I mean, in terms of a series circuit, you can understand that in terms of, well, it's going to drop more voltage, and so it's going to consume more energy per unit charge, and that should connect to the power, okay? And indeed, it does, okay? So that's the first of these little videos I'll do, and I'll put together a few more here. See you next time.